right, we have quite a bit of people tuned in today. I just want to say good afternoon, everyone. Thank you all for joining us today. I know it's definitely not easy during these unprecedented times. I'm Lucy Chen. I'm the marketing director here at Zemarc. And today we have a very special training by our world-class engineering team. It's going to be on the basics of industrial cylinders. So before we get started, I just want to give you a quick background on Zemarc. But we are very lucky to have two of our engineering team members here today, which is Chris Matuzik and Elizabeth Meyer. And as you know, we do have a t-shirt drawing at the end. We're giving away 3 t-shirts to 3 lucky attendees. So you have to stay tuned all the way to the end, and then I'll call out your names, and then we'll figure out the logistics after. So make sure you stay tuned. If you're not there and I call your name, you won't be getting the shirt. So make sure you pay attention. All right, so I just want you to know that Zemarc is a fluid power distributor. We've been in business since 1976, so we have over 40 years of a successful experience in this industry. So we provide cylinders, pumps, motors, valves, accumulators, filters, fluid connectors, and many more. We have 4 locations across California: Los Angeles, Oxnard, which is in the Ventura area, Fresno, and we also have Hayward. We also have representation in Arizona to support anyone that is there. Los Angeles and Oxnard are our 2 Parker stores, and we also have 2 hydraulic service centers that is located in Los Angeles and Fresno. We do test, we have a test bench that can support up to 100 horses. And as you know, or maybe you don't, but we are an authorized distributor and service center for Parker Hannifin, Enerpac, Lincoln, SKF. We also provide products like Delta Computer, motion controllers, MTS, and other fluid power products. If you're very interested in knowing what else we provide, you can go to www.zemarc.com/products. We offer full service repairs and a variety of hydraulic power units, cylinders, pumps and motor repairs as well, and inspections. We offer quick hose assemblies, services through all our locations, but we do have those 2 Parker stores, like I mentioned. One is in LA and the other is in Oxnard. I just want to give you a quick overview of some of the engineering solutions that we have. So we do offer a lot of assistance through hydraulic power units, which are also known as HPUs, standard and custom solutions provided. Our engineering team can assist you with both those options, and they can help you design and build all the other items in between. We do also offer different items like test stands, etc. If you're definitely interested, visit our website, give us a call. We're friendly, we're nice during these times as well, so just give us a ring. We would love to hear from you. All right, so lastly, I just want to mention that we have a wide range of products. Being a full line distributor of Parker, we can help you with your full application instead of just a portion of it. So our engineering team is excellent at supporting interoperability in your system. But today we're going to focus on the cylinders. So with that note, Chris Matuzik is going to start going over the training for today, which is the basics of industrial cylinders. Go ahead, Chris.
All right. Hello, everyone. My name is Chris. I am part of the engineering team at Zemarc here in Los Angeles, and we have a wide range of people here in the audience. So I'm going to start us off by kind of talking about the basic mechanics of how a cylinder works. So a cylinder is a linear actuator, as opposed to a rotary actuator like a motor. This means that fluid supplied by a power unit causes the rod to extend or retract. Now, if we strip a cylinder down to its basic mechanics, we have a piston in a hollow cylinder, which separates the bore into 2 isolated chambers. If we push fluid into one chamber, this pushes the piston to the other side and forces fluid out of the opposite chamber. If we attach a rod to one side of the piston, like we see here in the image, and extend it through the end of the cylinder, We can transfer this motion externally to a lever, a lift, a press, or whatever else it is that you want to move. This piston device is now a very basic double-acting single rod cylinder, which is the technical term for this type of cylinder we'll be discussing today. Now, the three basic dimensions of a cylinder are its bore size, which is the diameter of the piston, the stroke, which is the maximum distance the rod can travel, and the rod size, which is the diameter of the piston. So we're going to be talking about some operating parameters. First off, depending on the power unit and the system valving, a certain flow rate will enter the cylinder. A greater flow rate means that the rod moves faster, while a lower flow rate means that the rod moves slower. Changing the cylinder's bore also changes the rod speed. In this case, the relationship is inverse. A larger bore results in a slower rod speed. Now, keep in mind that because the rod displaces some volume in the rod chamber of the cylinder, less fluid is required to retract the cylinder. In short, this just means that with the same flow rates applied, a rod will retract faster than it extends, and also a larger rod will result in a faster retract speed. So we're going to talk about pressure as well. Uh, Pretty much basics are an external load acting on the end of the rod will be transferred to the fluid in one of the chambers. The piston here converts this force into static pressure in the fluid. Compression force induces pressure in the blind end, and tensile force induces pressure in the rod end. Now, pressure is the result of a force acting over an area, as we see here. In this case, the area is the area of the piston. So this means that the greater the force, the greater the pressure. However, at the same time, the greater the piston area, the lower the pressure. So this means that in order to increase the maximum force output of a cylinder, we must either increase the maximum applied pressure or increase the bore size of the cylinder. This is why you might see that construction equipment often operates at 5,000 psi, sometimes higher. This is to reduce the size of the actuators. On the other hand, stationary presses, which may be required to output several 100,000 pounds of force, use large cylinders to operate very high forces but at moderate pressures. Now, note that because the annular area, this is the area of the piston in the rod chamber, is reduced by the rod area, a single rod cylinder's maximum retracting force is always less than its extending force. So, all in all, the principles that I've explained are some of the basic tools that we use to size a cylinder. These principles determine the relationship between cylinder bore, stroke, and rod size, as well as the applied flow rate and pressure. To sum up, more flow to a cylinder or a reduced bore size increases its rod speed, keeping in mind that it retracts faster than it extends. And more pressure or a larger bore size increases its maximum force output. Again, keeping in mind that its extension force is greater than its retraction force.
Thanks, Chris, for covering all that and getting the basics down. For the rest of you, I am Elizabeth Meyer, a sales engineer at Zemarc, and today I'm going to be going over the important considerations when specifying a hydraulic cylinder. So most of us know going in that we need a certain force, speed, and length for a cylinder, but we can use that information to determine the bore and the rod, as Chris mentioned earlier. So here are some very basic design considerations. As mentioned, you need to know your force and your speed, but you also need to know the available footprint for placing your cylinder. So depending on your footprint, you might have to size your cylinder in a different way than expected, such as having a longer stroke or maybe a bigger bore to accommodate some length issues. Some other considerations are how you're going to mount the cylinder and different loading scenarios, such as side loading and buckling. In order to minimize side loading and buckling, the dimensions of the cylinder may need to be adjusted from what you've originally estimated. Our most commonly used heavy-duty cylinders, the 2H and the 3H, are rated for 3,000 psi, which is the limiting factor when we use cylinders needed to produce a large force. You're going to want to select a bore size of the cylinder to accommodate this maximum pressure along with your force requirement. Parker offers their 2H and 3H series in a tie rod design with a variety of common mounting options, including spherical bearings, flanges, and trunnions. You can often find 2H and 3H in many types of applications and is one of our most commonly used cylinders. Sometimes you need to use a more specialized cylinder for your applications. One of the most common cylinder types we deal with are for testing cylinders for fatigue tests. We use the Fast Series cylinder for these. And the Fast Series offer low friction piston seals and chrome plating in order to minimize the friction in the cylinder in order to do high cycle loads at fast speeds. We also have custom actuators when you need applications that require larger bores than you would normally expect and higher pressure ratings and unique mounting styles. Contact us, any of us at Zemarc, to help you size in and produce a custom designed cylinder. A variety of seals are available for each application with a cylinder. For non-standard hydraulic oils such as marine grade or Skydrol, different seal materials can be used. Low friction seals are often used in high-speed applications. Some other considerations like high pressures and severe temperatures will affect your seal choice.
And then there's Arctic seals, which are perfect for sub-freezing temperatures or also marine environments.
Thanks for that wonderful insight, Chris.
Of course.
Moving on. We have some different accessories that we offer for cylinders to help streamline your applications. One of the most key accessories you're going to have is what mounting style you're going to be using. We offer many mounting styles to accommodate your applications. The most commonly used industrial mount is the heavy-duty spherical bearing, but Parker has 19 different standard mounts available to suit whatever you need for your mounts. There's different rod ends available for mounting hardware to the end of the rod. Male and female threaded ends are the most common, but we also do provide flanges and options for custom mounting. So jackknifing is an issue that can occur in cylinders when the rod and rod bearing are very close and the rod bearing fails and breaks. This ruins your cylinder. In order to prevent having any jackknifing occur, you can add a stop tube, which prevents the cylinder from overextending. A very, very common accessory we find, especially if we're doing testing applications or anything that's going to be precision, is placing in linear position sensors. These can be installed directly in the cylinder, actually. You might be familiar with some ones like limit switches on the outside. Placing them on the inside keeps things very compact. For some of our most common switches are the ALS and global switch sensors, which can detect when they've passed certain points on the cylinder. If you're looking for higher precision, something like the wave scale sensor, which gives continuous positional feedback, would be the best option. So cylinder cushions are used to slow a cylinder by restricting exiting flow. This prevents the cylinder from being damaged by shock loads.
And they're usually also available with adjustable orifices as well.
No, that was not even funny. Let's just move on from that. All right. And so this is the Parker Hawes cylinder. This is a specialized cylinder that has a built-in power in it. What's really nice about the Hawes units is they provide the power of hydraulics and the precision of electric actuators in one compact unit. Here we have a reference chart with a lot of basic information on common Parker cylinders, so you can use this to get an idea of which cylinder you're going to be going for. So when you contact us, you already have an idea of what cylinder you want. It can help us fully design your cylinder for you. Just to summarize, when choosing a cylinder, you need to know the force and speed in order to size the bore, rod, and stroke. You also need to know your mounting conditions and consider what accessories your cylinder will need. This concludes how to size a hydraulic cylinder.
All right, thanks so much. So it's a very, very quick training. We went through a lot of the content quite quickly, but we hopefully got your seal of approval for this training. We are going to do a quick t-shirt draw, and then we're going to go into a Q&A with our engineers. So if you have a moment while we do this t-shirt draw, go ahead and enter your questions in the question channel on the left side of your screen. All right, so I'm going to do a random generator for all the attendees that are here. All right, I'm going to see if I can do a drum roll. That's my lovely dog trying to do a drum roll for you. All right, so the first winner is, thank you, Kiki. It is going to be Bob Apudaka. So I'll contact Bob and I'll let you know that we have sizes medium to 2XL. And then you can just provide me with the information on the ship to. All right, so next winner here is going to be David Morton. Congratulations, David. Congratulations, Bob. So again, it's medium to 2XL. I'll email you with some information on that, and then you can send me back what your ship to information is. So we have one more t-shirt, and that will be for Jim Van Patten. So congratulations, Jim, David, Bob, on winning the 3 t-shirts. I hope this training was helpful, and I'm going to go into question and answers. Let me look at some of these questions we have here. In the meantime, here's our contact information. You can feel free to email us at any time at sales@zemarc.com. We're also available on chat. I tend to be the one that picks up, so feel free to say hello to me. So you go to zemarc.com/chat, and that will help you open the chat box, or just go onto our website, zemarc.com. And our chat box is on the bottom right. You can see some helpful links here, which is zemarc.com/engineering and also zemarc.com/Parker Cylinders to get some more information. You can also call us at any time, Monday through Friday, 8 a.m. to 5 p.m. Pacific time. We are open regular hours during the coronavirus. We're fully staffed, but we are social distancing, and many of us are working at home, like myself. My dog is not at the office, unfortunately. But yeah. Well, we're welcoming anyone that wants to talk. So let's get some questions in here. All right, so I have Henry Sommer. You're having some internet connections, so I would say just refresh the page. It'll just reload for you. But Lewis, here's a technical question for Elizabeth and Chris. It says, I have a telescopic cylinder that bypasses. I have resealed, but it continues to bypass. Any suggestions?
So by bypassing, I'm going to assume you mean you're having some fluid leak out the rod end of the gland. For resealing, there could be a variety of issues. It kind of depends on your application. You might be overpressurizing your cylinder and going farther than the seals are rated for, or you're dealing with some fatigue. That's something where you can contact me and I can work with you and get some more information. It's hard to answer a question like this without any context.
All right. Thanks, Elizabeth.
If you need me, I can put my email in chat if you guys want to contact me, and I can help you guys with more specific questions.
Right, and there will be a presentation sending out at the within the next 24 hours with just a review of this entire video recording, but also the contact information of both our engineers and our sales team. We have one more question here that I see that looks like it's a good one. What do you recommend if I am using a highly corrosive fluid like Skydrol?
So when you're using a fluid like Skydrol, that's really going to affect your seals and possibly the materials. So I'd have to take a look at the chemical composition and compare it to the seals. Sometimes we're going to have to put on special plating on our pistons and bores just to make sure there's no corrosive issues. And definitely for something like Skydrol, specialized seal, we might have to go Viton or something even more advanced depending on your application.
Thanks, Elizabeth. We just got another question here from Ricardo. The question is, what is a rod bearing and where is it located?
Yeah, so Lucy, if you could actually scroll back up to one of the other slides that has a picture of a cylinder, it's much better to explain with an actual visual.
Yeah, sure thing. Let me find a good picture for all of us. Like the one that was actuating would be good, Chris?
Sure. So,
There you
um,
go.
there's actually no picture of a bearing in here, but I can show you where it is. Where the rod interfaces with the rod end of the cylinder, the bearing slides, or the bearing is a part of the cap there and slides against the rod. This is usually a kind of a sleeve bearing, kind of like you would find in an engine. And these are usually located inside a removable gland, which also contains the rod seal and the rod wiper, which keep fluid inside the cylinder and keep contaminants outside. These glands are easily removable, and you can purchase new ones for easy repair of most types of cylinders. Even mobile cylinders as well are designed with removable gland most of the times. But hopefully that answered your question.
Yeah, and here's we actually have one where it broke down all the components, but I'm trying to find. I don't know if you guys can see the numbers clearly
Oh yeah.
through the
So if you can
screen.
look at number 14 right there, that would be the gland, which contains the rod bearing, the rod seal, and the rod wiper as well.
Awesome, thank you. Let's see if there's any other questions here. Okay, so we have another question here from Dave, and that says, what application uses a breather valve and why?
All right, breather valves. I have not too familiar with the terminology. Oftentimes when I see, do you mean a pressure relief valve? That's might be what you're referring to. Almost every application uses a pressure relief valve in its system to minimize pressure loss. To minimize the pressure so you don't have an overpressurized system. Sometimes you'll place a relief valve directly on a cylinder if you're going to be dealing with lots of shock loads in which you expect your system to have periodic high forces on it that could damage the cylinder. These relief valves would be set to a certain pressure and relieve the back pressure in the cylinder to make sure it doesn't become overpressurized beyond its capacity. If you have more context for that question, I can definitely give you a better response if you can do a follow-up. All right.
Yeah, and like Elizabeth and Chris both said, feel free to reach out to them. I will provide an email with their contact information, but in the meantime, you can always feel free to respond, send your inquiries to sales@zemarc.com. We do respond rather quickly and get your information assigned. We're a very transparent team, so we do talk to each other. So we make sure you all get taken care of. So if there's no more questions, and listen, I'll give you guys a few seconds to type anything else. If there's no more questions, I would just like to thank everyone here today for attending. We had quite a good turnout, and I truly appreciate that, and I hope we were helpful. And I hope everyone stays safe and their families are well. It looks like there's no more questions.
Looks like we do have one more question.
Oh, okay. Go ahead. Let me see here. Oh, I see it now. Okay. So here's another question from Keith Johnson. Sorry, I made you type that rather quick. All right, so it's in a circuit operating at 3,000 psi working pressure in a static load holding application with a lock valve. Is it okay to have a thermal relief set higher than the working pressure, which is 3,400 psi? Here, I'll project this question so you can everyone can see it better.
All right. So this one, I believe, is one where it, again, depends on the context of your system. I'd like to have a better understanding before I could answer this particular question. Usually you do have your relief valves set higher than the working pressure because it takes a moment for the pressure to relieve. So if you set it at like 3,000 psi, you're actually going to relieve probably at something 2,800. So it depends on the valve if it's okay to set it to 3,400. If you have questions on that one, you can send me information on the valve and your system, and I can go through and verify if you should be at 3,400 or something lower.
Great, thanks, Elizabeth. I'll give you guys another few seconds if you have any other additional questions. And for any of you guys that are having any issues with the video feed, I would say refreshing would have worked, but since we're concluding the presentation, this presentation is recorded, so it will be provided to you in a hyperlink through an email within the next 24 hours. All right, let me just double check here. All right, I don't see any additional questions. So once again, thank you so much for attending, and I hope you have a wonderful day. Reach out anytime. We're here for you.